Welcome back. Up next, we'll hear from John Fristacci.
Hello? Can anyone hear me?
Yes, Greg, we can hear you.
Katie, have I been muted all this time?
Yes, you have.
Oh,
I
my
messaged
goodness.
you in the chat. I'm sorry.
Okay, yeah, I can't see my screen because when I've got the slides going. So pardon me for that. I'm glad somebody spoke up. Thanks, Greg. Anyway, I'm John Fristashi, former Tomcat guy. This is Calspan Flight Research, located in Buffalo with a flight research and artificial intelligence center of excellence up in Niagara Falls, New York. Our core business model is modifying the aircraft you see below for flight test of external stores, sensors, directed energy systems. We perform in-flight simulation and UAV surrogacy with these aircraft. The Air Force document depicted to the right here specified 4 components of airborne autonomy flight test requirements: runtime assurance, open systems architecture, surrogate test platforms, and live virtual constructive scenarios. And we were very pleased to realize that we had decades of experience with all of those in our aircraft. The schematic shown here depicts the actual switchology in the cockpit on the top left, and a schematic of our open systems architecture flight control computer residing between the artificial intelligence agent and our control actuators. The safety trip system therein can protect the airframe if the artificial intelligence agent does something to exceed the airframe's envelope or the capabilities of the pilots. The pilots can also manually trip the safety trip system. So this is a great risk reduction methodology for airborne artificial intelligence testing. The missions we've executed with the aircraft include remotely piloted aircraft. That was kind of step 1 in the crawl, walk, run. We've moved on to UAV surrogacy. We've tested artificial intelligence agents in multi-phase test management programs at the Air Force Test Pilot School. And we've performed in live virtual constructive scenarios and manned-unmanned teaming, like DARPA's Gremlins program. I'll start with our Learjet test beds. There are 4 degree of freedom capability control for your artificial intelligence agent. That means pitch, roll, yaw, and thrust control. You can see a depiction of the cockpit here in the center. The right side of the cockpit is dramatically different than the stock Learjet on the left, and that is our IP flight control system. We've replicated simulated flight dynamics for aircraft, including the X-47. In that case, the flight control computers were actually in racked computers in the cabin, as depicted in the upper right. We've also performed sense and avoid testing. That's a picture of that testing in the bottom left. It's the first test bed in a box capability. So it's like a software developer kit. We provide that to our customers. They're able to flight test and develop their artificial intelligence agents' control of the aircraft before coming to the airframe and flying it. And that's a great way to validate your algorithm before you have to put it on the airplane and pay for flight testing. Our Gulfstream G3s, depicted here carrying an advanced aerial refueling store, are basically an airborne test laboratory. We've outfitted these aircraft to take 8 flight test engineers aloft and test whatever systems that are necessary. Depicted here is a next generation jammer, satellite communication systems. The bottom left depicts a unique radar that one of our customers wanted to test. And our newest system is the autopilot experimental control system that enables an artificial intelligence agent to control the flight path of the Gulfstream through its autopilot. And we're just implementing that on these aircraft now. The depiction on the right is one configuration of the cockpit, or of the cabin, I'm sorry. It's a roll-on, roll-off, so you can put control stations back there for things like manned-unmanned teaming, as well as just monitoring your artificial intelligence agent or the status of your loyal wingman in that case. The X-62 Vista, again, it looks like an F-16. It is not. Its past performance include developments for Airborne Integrated Collision Avoidance System, and DEathClaw, which is an awesome Air Force acronym for Digitally Enhanced Aiming through Control Law. And what these have done is brought artificial intelligence into the Air Force fleet by using this test asset, validating the performance of their algorithms, and then fielding it across the Air Force enterprise. They're fielded throughout the F-16 fleet, making their way into the F-35 and C-130 fleet. We've upgraded the architecture of that airplane just this year, and it is now designated as by the Air Force as the world's preeminent AI experimentation testbed. We were pleased last week to see that Auto GCAS, which is part of Auto ICAS, had saved its 12th F-16 pilot from a loss of consciousness, G-induced loss of consciousness episode. So, that's a great example of developing artificial intelligence work on these test beds and then fielding it into the aircraft fleet. I'm going to go into a couple of things that we've done in the past. The top right picture depicts a live virtual constructive test that we performed where 2 Learjets flew formation at the behest of their artificial intelligence pilots amongst a swarm of virtual and constructive aircraft. You also see in the top center a depiction of our Gulfstream carrying an advanced aerial refueling store with our Learjet configured as a surrogate tanker or as a surrogate receiver aircraft. And I'll go into a little more detail on some of these. Autonomous landing flight tests, Project Atari. We flew the F-18 and then to be MQ-25 control algorithms in our Learjet at Niagara Falls at runway 28. They were transplanted then into an F-18 on board USS Abraham Lincoln, and those algorithms allow the LSOs to adjust.
Sorry to interrupt, but your slides aren't rolling forward. We have the not the presenter slide.
What are you on now?
Learjet testbed still.
Okay. I don't necessarily know how to fix that.
We got a new slide. We're on Atari now.
Okay. So depicted here, it shows the Learjet at runway 28 at Niagara Falls, and then below is the F-18 using those same algorithms, landing on board the Abraham Lincoln. Those algorithms will be used to allow them to adjust the flight path for autonomous systems landing on board the carrier in pitching deck operations. You should be looking at automated aerial refueling flight tests now. Can you see the Learjet with the refueling probe?
No, we're still on Atari.
Okay.
There you go. Now it's there.
Okay. Okay. Let me maximize this then. So what's depicted here is our Learjet configured with an inert refueling probe. The airplane was flown using the X-47's control laws, and the airplane autonomously rendezvoused on an Omega tanker, flew into pre-contact position, and was prepared to contact the drogue. You can see in the upper right picture depiction of the airplane actually engaging the drogue, becoming the first business jet to connect to an aerial refueling drogue. We're continuing that work today in the Advanced Autonomous Aerial Refueling and Transfer Flight Test Program. We're working with NavAir PMA 201, but the OEM for MQ-25 program is actually piggybacking on top of that to develop the relative navigation behaviors necessary for the MQ-25 to engage a refueling store. And so you can see a modified configuration on the nose cone on our Learjet in the bottom center picture. DARPA ACE, and let's see how we doing on time, Katie. I've got 5 more minutes. Looks like it. Okay, DARPA ACE is where we modified Aero Vodacody L39 using a scaled down version of our programmable fly-by-wire flight control system. We accommodated another provider's artificial intelligence algorithms and yet another's human machine interfaces integrating those systems into the L-39 so that it could dogfight autonomously. The success during phase 1 of that program convinced the Air Force to find a group of F-16s that are available for phase 2 and beyond, and we are competing to remain the integrator for those phases. So let me see if this automation will build here. You should be looking at CVN relevant autonomy.
Yes.
Okay, and we'll see if this works. Case 1, Hawking, you should see the vectors growing from various points in the overhead circle at the CVN. We believe that's feasible in the very near term to use our testbed aircraft in the carrier environment to demonstrate artificial intelligence algorithms that take over the Hawking capability and behavior set in the case 1 pattern. Also in the case 3 pattern, you see another depiction here that shows the case 3 pattern and the tanker Hawking. And we can do that both in the standard mode and also in a man-to-man teaming mode, simulating MCON tanking conditions. For tactically relevant behaviors, you should be looking at an OV1 with man-to-unmanned teaming and loyal wingman depictions. We would like to demonstrate electronic warfare scenarios and counter swarm scenarios. And using the Gulfstream, we believe that it is the perfect airborne testbed platform for white hat versus black hat cyber hackathons. And hopefully that's what's depicted here. I put the gratuitous lightning bolts on top of the OV1, simulating a threat vector and hackers trying to capture and take over the autonomous systems in a naval warfare scenario. We should be on the Calspan value slide. Our customers' feedback tells us that it's our vertically integrated capabilities and experience with artificial intelligence integration in an airborne scenario that allows them to execute their mission and keeps them coming back to us. We try to maintain a strong customer focus. We are a small, privately owned business, which we hope gives us speed and agility in our support to our customer set. And with that, we've got about 2 minutes left in the time period. You should be looking at a daylight depiction of our G3 testbed, streaming the advanced aerial refueling storage drogue for our Learjet. And with that, if there are any questions in the next 30 seconds, I'll be happy to take them. We would like to engage with the audience, and I apologize that the slides weren't advancing there for the in the beginning, and the audio wasn't coming through.
Great. And we can also put you in contact with anybody after this who has questions or would like to see those slides again.
Okay. I'd be happy to pass them along in a PDF format.
Great. All right. Well, we appreciate it. We will be now taking about a 5-minute break and starting our next presentation at 1:30.